Hey guys, my name is Vivek Sharma. Today we can cover this interesting problem that's called merge intervals. So in this kind of the problem we have been given the collection of objects and this object is predefined, that's called interval. And in this class interval they have been defined like start and end time itself. And so these are all basically start and end time, right? And we have to merge these start and end time together. We have to stitch together. So the criteria of stitching is basically, let's try to understand from the whiteboard. So let's say if it is let's take the pencil. Let's say I'm having two intervals 1 3 and 2 6, right? So 3 is of course greater than 2, so that's why I will just merge these is the 1 2 6 1 and 6, right? Because I will just stitch together. Let's take another example. Let's take the black color as well. Let's clear the board and let's take this is 1 4 and then 4 5 and third is, let's say, 7 comma 8, right? So what I will do 1 comma 5 and 7 comma 8, right? So this will be my output result. So what I'm doing here, if it is greater than and equal to, then I'm just simply merging 1 4 and 4 5, so it will be 1 5, and 5 is lesser than 7, so that's why I'm just not merging, right? And let's take other examples. So this is the way to solve any problem. Just go through a couple of examples and just try to see the pattern. Once we get the pattern we can just build the algorithms, but if we don't run through a couple of examples then it's little difficult and little tricky to understand the problem itself. So let's take other examples as well. Let's say 1 3 2 5, let's say 7 9, let's say 10 and 11. So let's say this is our input, right? And how we will merge these. So 3 is greater than and equal to 2, so this will be 1 5, and then 5 is lesser than 7. So 5 is lesser than 7, then what we are going to do. So 3 is greater than 2, so that's why we have just merged 1 and 5, and 5 is lesser than, so these are the disjoint set. 2 5 and 7 5, they are disjoint, so we will just mark it 7 9, and they are also disjoint. So 9 is not greater than, right? 9 is lesser than, so this is 10 11, right? So here the pattern is basically whenever we are finding this interval, if it is greater than or equal to the next interval, then we are simply merging. If it is not greater than equal to, then we are just considering it as a disjoint set and we are just making it another interval, right? That's what we are doing. And I wanted to show you that something else. Let's say this is 2 5 and let's say this is 1 3. So in this case what we are going to do, the result is still 1 5, but if you observe, like 1 is here and 2 is here, right? So another idea is we have to sort first of all, and if we don't sort then we will not be covering this kind of the case, right? Because where bigger start is here and lesser start is the next, right? So we have to sort first of all, and if we sort based on the start time itself, then I think we should be good, right? So if we sort is, it's like if it is 1 3 and 2 5, then we can easily see that okay, 3 is lesser than and equal to this 5, then we can just sort it, right? So this is one thing. Another thing is basically, let's say for my end time, let's say this is 1 7 and let's say this is 2 and 3, right? So in this case also 2 7 is greater than equal to 2, right? And so what will be the output here? It will be 1 7, right? 1 7. Why 1 7? Because 7 is greater than equal to, but this end basically it's uh, it's lesser than, right? So the earlier approach that we were discussing, okay, if it is end is greater than equal to, then simply merge. That will work considering that we will be finding the maximum end as well, right? If we will simply do, okay, if it is greater than, this end is greater than equal to next interval start, and just merge them, that's true, that approach is fine. But even after merging that, even before merging that, we have to calculate whatever the maximum end, right? So maximum end of 3 and 7 is 7, so we will mark it 7 here, right? So these are the couple of examples that we have to run through. Let's quickly create a couple of placeholders, then we will come back to the whiteboard and then we will just see that how our actual algorithm is building. But at least we know that we need the output result list, we need the sorting, and then we need to start and end as well. So let's create couple of skeleton, right? So once we are done with the skeleton, then we will just discuss the logic part, that how the logic is going to work. So this result list, basically we want it, right? So let's say if given input itself is null dot size, if it is equals to 0, then go ahead and return res. Then we just simply return the empty result list, right? And then intervals dot sort. Let's go ahead and sort our start time as well. How we are going to sort? We will just take the help of comparator. That's a built-in class for Java language. So interval. Now let's overwrite. Now let's override public int compare, right? And then here interval a comma interval b, right? So a dot start minus b dot start. So once we are done with that, then the next step that we were discussing, then we have to compare, right? So for the compare, let's take the start and end itself. So let's start is intervals dot get 0 dot start. Similarly, end will be like intervals dot get 0 dot end, right? So this is a start and this is end, right? So let's see, let's say we took already start and end. Now we have to iterate this start and end, right? So what we are going to do, if we took already that first start and end, whatever our start and end, we just need to compare this start and end with the next interval, right? And similarly we just need to keep doing. So we have to do the same thing. So why we will do I equals to 1? Because I equals to 0 we already took that, right? So intervals dot size I plus plus, and here we just need to check like if and is greater than equal to, right? So this and, right? So let's say first, this is the first index and this is zero index and this is first index, right? So this zero index we already took, and this and is greater than equal to 2, right? So that's what we are doing. Intervals dot get I dot start, and if it is greater than equal to, then we just discuss, right? So in this particular case we have to take the maximum of and, right? And if we don't take the maximum of and, then it will fail in this particular case, right? It may work like, for example, if it is 1 3 and then let's say 2 5, even if we don't take the and, we already know that okay, this 5 is already, next interval is already greater, right? So 5 is already greater. So in this case it might work, but it's not always the case, because we are not sorting based on the end, we are just sorting based on the start. So start, we are sure that start will be on the right position, but end we don't know, like whether it's earlier or whether it's a later part. So that's why we just need to take the maximum, whatever the maximum of end is there. So that's why we have to take the end is the maximum, math dot max and then intervals get I dot end, right? So that's what we need to do. So now we took the maximum end as well, right? So let's say in this example we have took the maximum end, and we already took came it here itself, and if we are having the lateral intervals as well, we will just keep doing the same pattern, we just keep repeating the same pattern itself, right? Let's try to clear the board and let's take this example here to build our logic. So let's do the text. Okay, so now let's see. Okay, so this 1 3, so this is 1 3 and this is 2 6, right? So 3 is greater than equal to, so what we build 6, we have took the end, right? And now we are iteration. So let's say this is 0 1 2 3, these are all the index. So now we are index at 1, right? Now we came to the index 2. Now our start is 8, and what is our end? End is 6. So 6 is greater than equal to 8? No, it's not greater. 6 is less than 8, right? So in that case, once we encounter that scenario, then we have to make our output list. We have to fill our output list. So in the output list, we can fill whatever the start and end is there. So start was 1 and end is 6, right? So start and end, right? So start is 1 and end is 6. So what we will fill in our output list? 1 6, and we are in the second location, and let's say our I is 2. Now I is on the 2, so let's say this is all the tracing that we are doing. So now we were already 2, so now we are 2, and now what is the new start is 8 and new end is 10, and now we move to the third index. So it's 15 and 18. So in the 15 and 18, let's say 10 is we came to the 15 and 18. So 10 is lesser than or equal to, so 10 is basically lesser than 15. So in the lesser than, what we are going to do, we are just disjointing. They are the disjoint set. So we are just making the filling our output list. So in our output list, what will be there? 18 and 10, and we were at the third index here. So third index, and we are just filling it 8 and 10. So these index, whenever we are filling these output lists, these are not the index that we are just in these index, these start time and end time is there. So don't confuse, because in the third index 15 and 18 is there, but I have written here 8 and 10, because at the third index we are making this start and end in our output list, right? So don't get confused with that. Or the second index, we are just filling our output list with the 1 and 6. So 1 and 6 is the maximum. 3 and 6, whatever the maximum is 6, and start is still 1. So now this is in our output list, and then after 15 18 we just came out of the loop. So we did not consider the 15 and 18. So in the end of this for loop, we have to again add 15 and 18 as well, right? And if we don't add, then this 15 and 18 will never be added. So these are all the steps we need to follow. Let's quickly convert them in the code itself. So here we just need to fill our output list, and in this output list, what we will do, this will be the new interval, right? Start and end, right? And now we need to take the new start and new end. So we need to reset that for the next iteration, right? So let's say if we were here on the second iteration and it's 1 6, and we are third, then we are reusing 1 and 6, right? And we are taking 8 and 8 and 10, we are just taking, okay, for the third iteration we are just reusing 8 and 10. So if you see observe the pattern here, whenever we are on the second iteration, we are just adding these 1 3 and 2 6. So that's why my start and end is 1 6. When I am third index, I am adding my previous start and end. So that's why this start and end is 8 and 10. And because there is no fourth, so I will just 15 and 18 I will be ending in the last. So that should be the pattern. So intervals dot get I dot start, and similarly end is intervals dot get I dot end. So these are all my start and end, right? So once these are redefined, then basically in the end, as I mentioned, I need to again add these start and end, because of the way that my algorithm is working. So return res. So I think this is the idea, right? So main logic is this one, all this for loop and then adding. So this is the main logic that we need to understand. Couple of takeaways and couple of quick summary for this problem. Couple of summaries, like basically we need to first of all sort based on the start time. Why we need to do that? Because if you will run couple of examples, you will understand that we need to sort based on the start time. Second is we are not sorting end time, right? That's why we are just taking the maximum of end here, right, to cover some of the cases, because we don't know where end is coming. It can be in any interval, it can be the previous interval, it can be the next interval. That's why we are just taking the maximum end, whatever the maximum end, and we are recording that. And once we found the disjoint set, then we are adding our intervals. So if you see the pattern here, we are on the second index, and we are adding our first start and end, whatever we calculated from the previous iteration. And now if we are on the third index, we are just adding 8 and 10. So 8 and 10 we just calculated on the second index, right? So whatever we calculated on the previous index, that we are adding in our the current index. So that's how it's working, and that's why we have to add this statement as well, res.end, right? To, in our example, to add 15 and 18, to add 15 and 18 from this example. And if we don't add this, then it will give the incomplete result. And let's quickly see that how it's giving the incorrect result. To just run this code. So this is 1523. I just modified this actually little bit, but let's quickly check whatever in the left side example, so that we on the same page, right? So this is 15 and 18, and let's try to comment this. And if I comment this, then my last interval will not be added here, right? So if you see this here, and if we see the difference 15 and 18, that's extra, right? So that's why we just need to necessarily add that result itself. Let's quickly try to see the time complexity and the space complexity itself, right? So time complexity will be n log n. Why it's n log n? Because n log n is basically for the sorting itself, and plus n itself, we are just traversing all the items itself. So n log n, and then it will be basically n log n itself, because n log n will dominate n itself, right? So space complexity will still be the n. So where n is basically the number of all the interval size. Because of this list of interval, it will be space complexity would be n. So quickly again, the couple of takeaways. First of all, we need to sort based on the start time, because of some of the examples we have seen. Second is basically after we have to take the maximum of end, right? And if we don't take the maximum of end, then we'll also be creating the problem, because we don't know like where the end is coming. So we have to take the maximum of end, right? Third is we have to take the disjoint set, where whenever we encounter the disjoint set, then only we need to add, right? And if we add in the same way, then the another pattern we can follow. Then we are in the second index, we are adding the start and end from the first index. Similarly, we are on the third index, we are adding start and end we got from the previous iteration, that's from the second index. So it's 8 and 10 we are adding on the third index, and that's why this is hanging around 15 and 18, and that's we are adding after for loop itself. So if we are clear about these patterns, then I think we should be good. But if we miss any pattern and we are getting confused, then I would recommend just run through a couple of examples again and again, and just see that why it's working, how it's working, and then it will be helpful. So let's quickly still did not submit, and let's quickly see that it's working fine. So I think this should be good, right? Hopefully it was useful. Thanks a lot for your time. Have a good one. Bye.